Step-by-step shake test. This video provides the steps of a standard, validated way of performing a shake test and evaluating the results, and suggests the correct actions for different outcomes. It also discusses the effects of freezing on absorbed vaccines and illustrates the mechanism behind the shake test. World Health Organization guidelines recommend that liquid formulations of vaccines containing diphtheria, pertussis, tetanus, hepatitis B, Haemophilus influenzae type B, and their combinations should not be frozen. Freezing of these aluminum-based adjuvant vaccines provokes loss of potency and, as a consequence, can result in compromised protective immunogenicity in recipients. When freezing is suspected, the shake test is the only test that can be performed in order to understand whether vaccines are affected by freezing and should not be used. When performed correctly, the shake test produces 100% reliable and valid results. Its sensitivity and specificity have been tested by the World Health Organization and confirmed at a 100% level against both freezing status and phase contrast microscopy. When to conduct the shake test. The shake test should be conducted when freezing is suspected. Freezing can only be suspected when temperature monitoring devices are checked. A freezing alarm can usually be found in electronic temperature monitoring devices accompanying international shipments. Although a thermometer is not an ideal temperature monitoring device, it can show that the current temperature of the refrigerator is below zero. Likewise, the storage facility alarm system can warn responsible officers about freezing. Similarly, freeze indicators can also warn health workers about freezing temperatures. In all these situations, the shake test should be conducted. The shake test should not be conducted under these circumstances. When the vaccine is already frozen solid, there is no need to conduct the shake test. Such vaccines must be discarded according to standard disposal procedures. Some DTP vials, when exposed to sub-zero temperatures without freezing, develop white lumps of sediments that are attached to the walls of the glass vial. A homogeneous solution cannot be obtained despite vigorous shakings in such vials. The shake test should not be conducted on such vials, and they should also be discarded. How does the shake test work? The shake test is designed to determine whether absorbed vaccines have been affected by freezing. In order to understand how the shake test works, let us take a closer look into a freeze-sensitive vaccine vial. The main structure of the freeze-sensitive vaccine is its lattice structure, the structure that bonds the absorbent and the antigen. After freezing, this bond is broken. Separated absorbent tends to form granules that get heavier in weight and bigger in size. After the vial is shaken, the granules gradually settle at the bottom of the vial. This structural difference can also be seen in phase contrast microscopy. Following shaking, sedimentation occurs faster in a vaccine vial that has been frozen compared to a vaccine vial of the same antigen and batch from the same manufacturer that has never been frozen. It is simply physics. A solution with heavy particles sediments faster. The shake test is about observing the sedimentation rate between a suspected vial and a vial that has been purposely frozen and used as a control vial. Step by step, how to conduct a shake test. The WHO has developed a standard shake test learning guide that can also be used as a checklist. The steps described in this guide must be followed thoroughly. The first step in conducting the shake test is to prepare a frozen control vial. Take a vial of vaccine of the same type and batch number as the vaccine you want to test. It should also be made by the same manufacturer. If more than one batch is in question, a frozen control sample should be prepared separately for each batch, and each batch should be tested with its own control sample. This vial must be clearly marked as frozen. Place the vial in the freezer compartment of the refrigerator overnight until its contents are completely solid. Now, your control vial is ready. Let it thaw. Do not heat the vial, but you can keep it in your hands for it to thaw faster. Once your control vial is thawed, you are ready to conduct the shake test. For demonstration purposes, we will use 2 test vials in this video. Take your suspected vials, which are the test vials, and hold them together with the frozen control vial in one hand. Shake all vials vigorously for 10 to 15 seconds. Place the vials on a flat surface side by side and start continuous observation of the vials until the test is finished. An adequate light source should be used to compare the sedimentation rates between the vials. Most of the time, somewhere near a window is ideal. If the vials have large labels that conceal their contents, turn them upside down and observe sedimentation in the neck. We will fast forward the video for you to see the difference in a shorter period of time. There could be 2 outcomes in a shake test. If the test vial sediments slower than the frozen control vial, this means the test vial is not affected by freezing and can be used safely. If the sedimentation rate is similar in both vials, or if the test vial sediments faster than the frozen control vial, this means that the vaccine has been affected by freezing and is damaged. Let's see it again. The vaccine on the left side of the control vial is sedimenting at a similar rate as the frozen control vial. This vial has been frozen and is affected by freezing. This is a fail result. The vaccine on the right side of the control vial is sedimenting slower than the frozen vial. This vaccine has not been frozen. This is a pass result. All affected vaccines producing a fail result must be discarded and cannot be used. The shake test requires patience. If you are not sure whether there is a difference in sedimentation rates, you must wait and continue observing until you are certain. This is why the time definition for fail or pass is not given for the shake test. One health worker may decide a fail result, say within 2 minutes, while the same vial could be diagnosed as fail in 5 minutes by another health worker. If all health workers patiently observe the sedimentation rates, regardless of their time of decision, they will diagnose the test vial correctly. When freezing is suspected, wherever you are, the shake test is the only tool available to confirm whether suspected vials can be used or not. The shake test has been validated by the World Health Organization and is 100% sensitive and 100% specific. It correctly identifies all frozen and non-frozen vials by comparing them to a frozen control vial. All you have to do is to follow the learning guide.